Hi, pre-calculus students. Welcome to section 5.4, sum and difference formulas. These are numbers on your chapter 5 memorization sheet, number 4 and 5. You will not have a memorization quiz on chapter 5. I've normally given that in the past, but given our interesting year, it's just a sheet to help you on your homework, on your quizzes, on your tests, okay? But there's only, this chapter only goes up to 5.5. So we're already almost there. So what this section is about is sum and difference formulas for sine, cosine, and tangent. And of course, that would be for cosecant, secant, and cotangent too, because we could just use the reciprocal, right, values for that. So what you saw, I'm going to do a look at number 2 first and then go to number 1. Number 2, we did a no trig warm up that showed, for example, that cosine of 30 degrees plus cosine of 45 degrees is not equal to cosine of 75 degrees, right? And we saw that wasn't true. So this means for this expression and others that there must be other formulas we need, but I just wanted to show you why this is true. So I drew pictures, right? Pictures always help with trig. And what I did is in purple, I drew a cosine of 30 degrees, right? So here's a unit circle and we know cosine is the x value. So here's a 30-degree angle and the purple line is the length of cosine, right? And then plus cosine of 45. So I drew a 45-degree angle and the blue line there is the x value is cosine. Well, notice that 30 plus 45 is 75. So it might lead you to believe that cosine of 75 would equal cosine of 30 plus 45, but we can see this must not be true. Here is cosine of 75 degrees. Right, and here is that horizontal side, that x value. It is much shorter than the purple length or the blue length. There is no way that the purple length plus the blue length can equal the squiggly black length, which is cosine of 75, right? Based on the picture that we see. So this means that we need formulas. And here they are. Again, you don't have to memorize them, but I just want you to see the patterns that I see so that's easier to write them. First of all, notice it's some angle, first angle U plus a second angle V. Notice in all these formulas, the U and the V stay in order. U, V, U, V, U, V, U, V, U, V, U, V. They all stay in order. Notice also that with sine, the sign in the middle stays the same. So if you are adding two angles, you will have a plus sign in the formula. If you are subtracting two angles, you will have a subtraction sign in the formula. Notice that is not true of cosine. If you are adding two angles with cosine, you would have a subtraction, right? If you're subtracting two angles, you would have an addition. How do I remember this? Again, not that you need to, but when it's sine, the sign stays the same, okay? Here's another thing, cosine, like co-workers. Okay, meaning that the cos go together. So when you have cosine of two angles being added, subtracted, you have the cos first. Co-workers, they go together, and the sine second. Okay, with tangent of two angles being added or subtracted, the way I remember that is that if you have tangent of u plus v, the numerator is also tangent u plus v, and the denominator has the opposite sign, 1 minus tangent u times tangent v. If you have tangent of two angles being subtracted, you have a subtraction sign in the numerator and a addition sign in the denominator. Again, it just helps you when you're writing it instead of just bits and pieces like, oh, that's right, I kind of remember how these things work. Now, why do we use sum and difference formulas? We use them in calculus. It gets us a couple more exact values than what we have on the unit circle. It gets us some more identities and proofs, and it's fun. Believe it or not, it's fun. But otherwise, there's not that many uses in the real world. How do we use this? So here's what we do. Any problem that they've given us, A, B, C, D, or E, we look at the pattern and we decide which of the identities that we have. Then we fill in the identity with information we have been given. And if we are missing any information, we will have to find it. We will do our math. That can actually be the hardest part. And we may use degrees or radians. Okay, so for number 5, we're going to do some examples that are listed. And what I'm going to do, I'm going to try to do my best to bring you closer, right? Because it's just a small part of the board here. Let's see if I can bring you closer to me. And we will work on these problems here. So find sine, cosine, and tangent of 7 pi over 12. Now, just so you know, number A, don't get discouraged, I think is the hardest problem, perhaps, that you will see up here. Okay, notice also that they did tell us that 7 pi over 12 is pi over 3 plus pi over 4. That is in fact true. Okay, let's take a look at why. This is 60 degrees plus 45 degrees is 105 degrees. And 7 pi over 12 is 15, right, times 7. So it comes out to be the same. Okay, another thing you could do is get a common denominator. If I made both of these denominators 12, I would have 4 pi over 12 plus 3 pi over 12 is 7 pi over 12. Okay, so they are asking, or we could, right, just switch it to degrees. Okay, so let's first find sine, cosine, and tangent of 7 pi over 12, okay, by writing it as sine of pi, 7 pi over 12 is sine of pi over 3 plus pi over 4. Okay, and let's do cosine of 7 pi over 12 is cosine of pi over 3 plus pi over 4. Okay, so the first thing we do is, and then we'll do tangent. The first thing we do is identify what condition we have going on. Here we have sine of 2 angles being added, where my first angle is U and my second angle is V. And so I have my formula on the board here, right, that you have in your notes or on your memorization sheet. I'm going to talk it through. That would be sine of pi over 3 times cosine of pi over 4 plus, because the sign stays the same, that would be cosine of pi over 3 sine of pi over 4. Okay, and I know all of these values, 1, 2, 3, 4. I know what these are. Sine of pi over 3 is, and I have my unit circle just because there's so many details, I didn't want to mess it up, but I also have my left hand, right? Sine of pi over 3 is the square root of 3 over 2, right? Times the square root of 2 over 2, plus cosine of pi over 3 is 1/2. Sine of pi over 4 is the square root of 2 over 2. Notice what I get then is I have a common denominator of 4, and my numerator is the square root of 6 plus the square root of 2. Your book might write the solution differently, but this is what I see. Cosine of 7 pi over 12 is cosine of pi over 3 plus pi over 4, right? And so that is cosine of 2 angles being added. I'm looking at the formula right here. You have it in your notes. That would be cosine of pi over 3, cosine of pi over 4, minus sine of pi over 3, sine of pi over 4. Again, the idea is when it's cosine, it's the cos go together. Because it's not sine, the sign changes, but you have your formula sheet. And U is pi over 3 and V is pi over 4. 1, 2, 3, 4. I know these pieces of information, right? Cosine of pi over 3, I already did, right? I already did all these. This time I'll use parentheses 1/2. Cosine of pi over 4, square root of 2 over 2. minus sine of pi over 3 is the square root of 3 over 2. Sine of pi over 4 is the square root of 2 over 2. Right? And so what I get here then is a denominator of 4 and a square root of 2 minus a square root of 6. Your book may show it different, but there you go. Now, for tangent, notice I could do sine divided by cosine, right? But it's kind of ugly. So I'm going to tell you right now, class, it's a little ugly, the tangent, but we can do it, okay? So what I'm going to do is I want to use the formula. Again, I could do sine divided by cosine, but we have a formula and I want you to have practice using it. So here we go. Tangent of 7 pi over 12 is tangent of pi over 3 plus pi over 4. And what is my situation? I have tangent of 2 angles being added. That would be tangent of pi over 3 plus tangent of pi over 4 divided by 1 minus those same values, tangent of pi over 3, tangent of pi over 4. Now this is perfectly correct. What a mess though, but we know, for these items, we know what they are. Tangent of pi over 3 is the square root of 3 and tangent of pi over 4 is 1. 1 minus, again, the same values, which would be the square root of 3 times 1. So again, this is perfectly correct here, this answer, but we don't leave it with the square root in the denominator. So we multiply by the conjugate of the denominator. The conjugate of 1 minus the square root of 3 is 1 plus the square root of 3. Okay, so let's go back on over here. Let's do the denominator first, because we know when you multiply conjugates, you only have to do the first and the last because the outers and the inners eliminate. So this would be 1 minus the square root of 3 times itself is 3. Now, the numerator, oops, made a mistake here. There we go. Ooh, ooh, ooh. Better. I obviously have to multiply the numerator and denominator by the same thing. I'm going to carefully do first, outer, inner, last. So first is the square root of 3. On the outside, I have a 3. On the inside, I have a 1. Last, I have a square root of 3. Okay, what a mess, right? Here we are. All right, so we have 2 square roots of 3 plus 4 over a negative 2. And notice that we can divide each of these by a negative 2. So I have 2 square roots of 3 over a negative 2. I'm just going to split it up. Plus 4 over a negative 2, right? I just split it up. That's all. And I get a negative square root of 3 minus 2 is our final answer. Wowzy, right? It actually wasn't so hard doing the problem, like filling in the formula. It's the algebra. I'm going to press pause. Hopefully I'll remember to turn it back on and get ready for B. Okay, we're back. I found that I put for B, find exact value of cosine. I had a 70 here, I meant a 75. And so I fixed it. Find exact value of cosine of 75 degrees. Use your unit circle values. How come? That's where your exact values are, right here, okay? And notice that we said, well, we can't find cosine of 75 degrees this way by doing cosine of 30 plus cosine of 45. So what do I do? Okay, so notice what's happening here is they want cosine of 75 degrees. That exact value is not on the unit circle, right? So what do? I find 2 angles that are on the unit circle and either add them or subtract them to get 75, right? So I am going to write cosine of 75 as cosine of 30 degrees plus 45 degrees, right? Because these 2 angles really do add to 75 degrees. And now I know to use the cosine of two angles being added formula. What else could I use? I wish I had thought of this, but I could use the subtraction of two angles. Let's see. That won't work. 98, just looking at, oh, hold on. Be right with you. Oh, okay. I could also use, just so you know, cosine of 135 degrees minus 60 degrees, right? These angles are on the unit circle, and 135 minus 60 is 75, right? But I like my 30 plus 45 better because those values are in the first quadrant, and I'm just better with it. But either way, you'll get the same answer, okay? So let's take a look. So my situation is I have cosine of two angles being added. I'm going to fill in that formula. That would be cosine of 30 degrees times cosine of 45 degrees minus, because it's not sine, the sine is not the same, a sine of 45 degrees. Oh, sine of 35. Sine of 30. Now I'm just saying anything. I'm just like saying anything. Sine of 30 degrees and sine of 45 degrees, right? Because with the cosine, the cos go together. Let me check and make sure I wrote this right. Cos, sines, 30, 45, 30, 45 minus sine in between because I have a plus. I got it. Okay, 1, 2, 3, 4. We know these values, right? Cosine of 30 degrees, that's the square root of 3 over 2. Cosine of 45 is the square root of 2 over 2 minus sine of 30 is 1/2. Sine of 45 is the square root of 2 over 2. There we go. All right. So our final answer here is our denominator is 4 and our numerator is the square root of 6 minus the square root of 2. You know, big deal. So this is the exact value, you know, for cosine of 75, but I hate it. Who really cares? Like, do we need one more exact value? I just also want to point out the back of your book and other places might do this. Do you see right here and right here in both of these terms that there's a square root of 2 over 2 in common, and there's a 2 in the denominator in common. So you may see the answer as the square root of 2 over 4. Like they'll factor the square root of 2 over 4 out, and that leaves a square root of 3 in the first term minus a 1 in the second term. So these are both the same, but you might see this instead in a book or on Delta Math or somewhere else. Okay, let's try C. Okay, on C, they want you to find the secant of two angles being subtracted if U and V are in the fourth quadrant. What? And sine of U is a negative 5/13 and cosine of V is a 4/5. Wow. Okay, first of all, to find secant, oh, I want a black marker. To find secant, again, this is C, of U minus V, I am instead going to do, because I don't have a secant formula over here, right? I'm going to do 1 over cosine of U minus V, right? Because the reciprocal of cosine is secant. So this is what I'm going to do instead. Okay, so my situation is that I have cosine of two angles being subtracted, right? And so I know what formula to use, and then I'm going to take the reciprocal of it. So I have 1 over, I'm going to have cosine of U, cosine of V, plus sine of U, sine of V. Okay, so if I had these 4 items, these values, I could put them in and take the reciprocal. Okay, what do I do here? What I do is they gave me some information. I do need to draw U and V in the fourth quadrant. I am going to do 2 separate pictures. Here's U. I'm going to make U in the fourth quadrant. Here's V. I'm going to make that also in the fourth quadrant. Okay, so I've taken care of secant of U minus V. I've taken care of putting U and V in the fourth quadrant. Now they gave us some information about U. They are saying that U, so I'm right here, is a negative 5/13. Okay, that would be opposite over hypotenuse. Okay, notice that sine of U, I'm in the fourth quadrant, you would tell me is negative 5/13. Okay, I took care of this. Cosine of V is 4/5. Okay, so here's V, 4/5 would be a picture of this, right? So if I asked you what is cosine of V, you would tell me 4/5. Okay, so let's go back to our formula. Notice that I do have cosine of U, I do not have. Now cosine of V, I do have. It is 4/5. Right here, cosine of V, I have. It is 4/5. Plus sine of U, I do have, right, sine of U, negative 5/13. Sine of V, I do not have. Okay, but can't I get cosine of U and sine of V from my pictures? Let's go to U right here. Notice that I can find the third side by using the Pythagorean theorem, and it would be a 12. Am I right? This would be 169 minus 25. Yeah, would be 144, right? And the square root of that would be 12. And notice that it's positive. So now I do see what cosine of U is. It's 12/13. And I'm going to put it right here for cosine of U. Notice in my picture of V, right, I can find this third side, right, by using the Pythagorean theorem. It's a 3 and it's negative, right? That's why we needed to know about the fourth quadrant. So sine of V, I now know for my picture, it's a negative 3/5. And I'm going to put it right here. All right, I now have everything I need to find the denominator. And then once I do, I can take the reciprocal of it. Notice that we do have a common denominator of 13 times 5 is 65. And here we have 48 plus 15 is 63. So we have 1 over 63 65ths, which is 65 63rds. And that is secant of these two angles with the given information being subtracted. That's a doozy. Let's do D. Okay, on problem D, they want us to rewrite sine of 3 cosine of 2.6 minus cosine of 3 sine of 2.6. So just like my other problems, I need to identify the sum or difference formula that we have going on. Okay, first of all, I have sine, cosine, cosine, sine. This must be sine, because if it was cosine, I would have two cos right here, right? And if it was tangent, I would have a lot of tangents in here, okay? And it must be, because there's a minus sign here, this must be sine of two angles being subtracted, right? Where, right, because this formula, let's write it out, is sine of U, cosine of V, minus cosine of U, sine of V. So when you take a look here, take a look, our U must be 3, right? Our U must be 3. And our V must be 2.6. There we go. So an equivalent expression to the expression we were given is sine of an angle 3 minus an angle 2.6, which would be, I can actually subtract these angles, sine of 0.4. Excellent. All I had to do was identify my situation and the angles and actually do a little bit of easy math. Last problem. We can do more proofs. We can prove that sine of pi minus theta plus cosine of pi over 2 minus theta is equal to 2 sine of theta. Holy cow. All right, let's start with purple here. Sine of pi minus theta, right? That is sine of two angles being subtracted, where my first angle is pi and my second angle is theta. Don't worry too much that you don't know what theta is. Let's just apply the sine of two angles being subtracted formula. That would be sine of pi times cosine of theta minus, and that would be cosine of pi times sine of theta, right? I'm just going to make sure I wrote it right. I think so. Okay, now plus, right? Here's where I am right now. Plus, there we go. Now I'm going to apply the formula cosine of two angles being subtracted. And I know what that formula is. It is cosine of pi over 2 times cosine of theta plus sine of pi over 2 sine of theta. And apparently this is equal to 2 sine of theta. Wow. This is how you know you're in pre-calc, right? Okay, so what do I do next? What I do next is I do know what sine of pi, cosine of pi over 2, and sine of pi over 2 are. I know what those are from the unit circle. And so I'm going to fill those in. So sine of pi is 0, right? So, and 0 times cosine is 0. I'm just going to cancel that out. That's 0. Okay, minus, don't lose your minus sign there. Cosine of pi is a -1 times sine of theta. Okay, plus, I'm at that middle plus sign. Cosine of pi over 2 is 0 times cosine, so this is 0. Sine of pi over 2 is 1 times sine of theta equals 2 sine of theta. We'll take a look here. In my first term, I have two negatives make a positive. So I have sine of theta plus sine of theta. That's 2 sine of theta equals 2 sine of theta. And it's true. And we're done. We proved it. Wow, there's a lot going on there, isn't there? You have a wonderful day.